Dear learners, welcome to the chapter on Information Technology Architecture. This session will focus on data resource management with the deliberations on data warehouse and data mining. Let us now discuss about data warehouse. A data warehouse stores data that has been extracted from the various operational, external, and other databases in an organization. They store current and historical data, and are used for creating analytical reports for knowledge workers throughout the enterprise. Examples of reports could range from annual and quarterly comparisons and trends, to detailed daily sales analysis. The data stored in the warehouse is uploaded from the operational systems such as marketing, sales, HR, operations, production, and so on. Data warehouse may be divided into data marts, which hold subsets of data from the warehouse, that focus on specific aspect of companies such as a department or a business process. The data from various operational and external database are captured, cleaned, and transformed into data that can be better used for analysis. The data in data warehouse is static due to complex patterns of historical trends that might otherwise go unnoticed, with dynamic data that change constantly. Diagrammatically, a data warehouse is represented below to understand the inflow and outflow of data to and from the data warehouse. The building of data warehouse is done in phases which are discussed here. The first phase is logical and physical design phase, in which the database engineers decide the schema, subschema, data structure, and how data will be stored to, and accessed from the data warehouse. The second phase in building the data warehouse is the extraction phase. The builders creates the files from transactional databases, saves them on the server, which will hold the data warehouse. The next phase is the cleansing phase. The modification of data is done in this phase to allow appropriate insertion of data with uniformity. For instance, New Delhi could be stated as Delhi, Delhi, ND, Delhi, Delhi, New Delhi, etc., and thus the information is checked for data inconsistencies by applying data integrity rule prior to storing it. The fourth and last phase in building the data warehouse is loading phase. In this phase, information is uploaded in the data warehouse, mapping it with the structure of a data warehouse for further use. Here we will see the guidelines that organization must adhere to for quality implementation of a data warehouse. First, build incrementally. Data warehouses must be built incrementally. Generally, it is recommended that the data marts may be created with one particular project in mind, and once it is implemented, several other sections of the enterprise may also want to implement similar systems. An enterprise data warehouses can then be implemented in an iterative manner, allowing all data marts to extract information from the data warehouse. Second, need a champion. A data warehouse project must have a champion, who is active to carry out considerable researches into expected price and benefit of the project. Data warehousing projects requires inputs from many units in an enterprise, and therefore needs to be driven by someone who is needed for interacting with people in the enterprise, and can actively persuade colleagues. Third, senior management support. A data warehouses project must be fully supported by senior management. Given the resource-intensive feature of such project, and the time they can take to implement, a warehouse project signal for a sustained commitment from senior management. Fourth, ensure quality. The only record that has been cleaned, and is of a quality that is implicit by the organizations, should be loaded in the data warehouse. Fifth, corporate strategy. A data warehouse project must be suitable for corporate strategies and business goals. The purpose of the project must be defined before the beginning of the project. Sixth, business plan. The financial costs of hardware, software, and manpower, expected advantage, and a project plan for a data warehouse's project must be clearly outlined and understood by all stakeholders. Without such understanding, rumors about expenditure and benefits can become the only source of data subversion of the project. 7th, training. Data warehouse projects must not overlook data warehouse's training requirements. For the data warehouse project to be successful, the stakeholders must be trained to use the warehouse and to understand its capabilities. 8th, adaptability. The project should be built with flexibility, so that changes may be made to the data warehouse, if and when required. Like any system, a data warehouse will require change, as the needs of an enterprise change. 9th, joint management. The project must be handled by both IT and business professionals in the enterprise to ensure proper communication with the stakeholders, and since the project is designed for assisting the enterprise's business, the business professionals must be involved in the project, along with technical professionals. Let us now understand the next topic of the session, data mining. Data mining is a technique which leads to extracting relevant data from data warehouse and databases. In data mining, data in a data warehouse is analyzed to reveal hidden patterns, correlations, and trends in historical business activities. This helps managers to take strategic decisions about business operations and gain competitive advantage in a marketplace. Data mining software uses advanced pattern recognition algorithms, as well as a variety of mathematical and statistical techniques, to sift through mountains of data and extract previously unknown patterns for strategic decision-making. In other words, data mining is a process of selecting, exploring, and modeling large information from the sea of information available in any business environment. It is a process applied to discover the previously unknown relationships from the data and information that already exists within an organization. These relations might not be thought of otherwise, in regular course of working. Strategic use of data mining is enormous, few are given here. Market basket analysis, sales forecasting, inventory planning, tracking customer loyalty, fraud and intrusion detection, customer segmentation, health diagnosis, logging customer and suppliers, trend analysis, to name few. One should remember that information failures lead to sluggish policies. DRM has opened a world of possibilities for businesses. The field of modeling the data and using it for analysis through computational statistics is a basis for business policy and strategic planning. Dear learners, this brings us to the end of our discussion on the current topic. Thank you for following the content. Best wishes for all your endeavors.